In this video, we're going to talk about the substitution method, but first let's talk about differentials. Y is equal to f of x. The derivative dy dx is equal to f prime of x. Now multiply both sides by dx. We get dy, the differential dy, is equal to f prime of x times the differential dx. Let's look at some examples. Y is equal to x to the 5. Its derivative dy dx is equal to 5x to the 4th. Now multiply both sides by dx and we get dy is equal to 5x to the 4th dx. Let u be equal to sine x. Let's take its derivative du dx is equal to cosine x. Now multiply both sides by dx and we get differential du is equal to cos x times differential dx. U is equal to e to the x. Du dx, derivative of an exponential is itself, that's going to be e to the x. Multiply both sides by dx and we get differential du is equal to e to the x times differential dx. Let's look at another example. Let u be equal to arc sine minus 1 of x. Du dx, its derivative is going to be 1 over root 1 minus x squared. Du, the differential du is going to be 1 over root 1 minus x squared times differential dx. Now let's look at the chain rule. After all, the U substitution method is really the reverse of the chain rule. So we have y is equal to f of g of x. This is a composite function. And y prime, the derivative, is going to be f prime, the derivative of the outer function. Keep the inner function intact, f prime of g of x. Now differentiate the inner function and multiply by g prime of x. This is the chain rule. Let's look at some examples. Example. Y is equal to sine of x squared. Y prime is, the derivative of sine is cosine. Keep the inside intact, cos of x squared. Now multiply by the derivative of the inside, derivative of x squared is 2x. Another example. Y is equal to exponential e to the x squared. Y prime will be, derivative of an exponential is itself, that's e to the x squared. Keep the exponent intact, multiply by the derivative of the inside, that's 2x. Now let me clarify this question a bit. Y is equal to exponential of x squared. So the x squared that you see in the exponent is really inside the exponential bracket. So y prime will be exponential of x squared, keep the inside intact, then multiply by the derivative of the inside, that's multiplied by 2x. Alright, another example. Y is equal to tangent of x squared. Derivative of tan x is secant squared x. So y prime will be secant, keep the inside intact, sec of x squared, the whole thing gets squared. Now multiply by the derivative of the inside and derivative of x squared is 2x. Another example. Y is equal to ax plus b to the power of n. The derivative, applying the power rule, will be bring the power down, n times, keep the inside intact, ax plus b. Subtract 1 from the exponent, that's n minus 1. And then differentiate the inside, that's just a plus 0, because derivative of a constant is 0. So let's simplify that. That's n times ax plus b to the power of n minus 1 times a. Let's look at one more example. Here we have y is equal to log of x squared plus 1. The derivative dy dx is going to be 1 over the inside, 1 over x squared plus 1, times the derivative of x squared plus 1, derivative of the inside is just going to be 2x. That simplifies to 2x divided by x squared plus 1. All right, we're now ready to talk about the U substitution method. So we have integral f of g of x times g prime of x dx. We start by letting u be the inside function. Let u equals g of x. Differential du is equal to g prime of x dx. So what we have, this part here is going to be f of u, and g prime of x dx, that's just going to be du. All right, so we have integral f of u, integrate with respect to u, and that's going to give us capital F of u, because capital F of u is the antiderivative of f of u, plus c. And that's going to give us f of g of x, substitute u back in, f of g of x, plus c. All right, so now let's look at some guidelines. Step 1, substitute u equals g of x. So you have to make a choice of u, and finding that choice sometimes can be a bit of a challenge. But generally, you can let u be the inside function, or the more complicated part of the expression. After doing some practice, you'll get a general idea of how to choose u. The differential du will be g prime of x dx. Step 2, transform the integral f of g of x, g prime of x dx, into integral f of u du. And now this integral hopefully will be easier to solve. So integrate the simpler function f of u with respect to u. And step 4 is substitute u equals g of x and obtain the result in terms of x. All right, let's look at some examples. Here we have integral 1 over 2x plus 1 dx. We start by letting u be equal to 2x plus 1. The differential du is equal to 2 dx. If we solve for dx, that's going to be du over 2. Let's put this in a box. All right, so we have integral 1 over and 2x plus 1, that's going to be u, and dx is equal to du over 2. Now the 1/2 is a constant, we can pass it through the integral, we get 1/2 integral 1 over u du. And integrating 1 over u, we'll get 1/2 log of absolute value of u plus c. Now plug u back in, and u is equal to 2x plus 1. So we get 1/2 log of absolute value of 2x plus 1 plus c. All right, let's look at another example. Here we have integral x over x squared plus 1 dx. You will notice that the numerator x is a constant multiple of the derivative of the denominator. If you differentiate the denominator, you will get 2x. So that's why we're going to let u be equal to the denominator x squared plus 1. Differential du is going to be 2x dx. Now let's solve for x dx. So x dx is equal to du over 2. So what we have is 1 over x squared plus 1. Let's rewrite this. Times x dx. So this part of the integrand is going to be 1 over u. And this part is going to be du over 2. And we're going to integrate that with respect to u. All right, so what we have is integral 1 over x squared plus 1 times x dx. And we have simplified this to integral 1 over u times du over 2. So we have integral 1 over u times du over 2. Now the constant 1/2 passes through the integral, so we get 1/2 integral 1 over u du. And antiderivative of 1 over u is just going to be log of absolute value of u. That's 1/2 log of absolute value of u. And don't forget to add the constant of integration, plus c. So that's going to be 1/2. Now substitute u back in. That's u is x squared plus 1 plus c. Now, note that absolute value of x squared plus 1 can be written as just x squared plus 1. The reason for that is because x squared plus 1 is positive, so we don't need the absolute value. All right, so the integral x over x squared plus 1, we calculated this integral using the substitution method, and the result came out to be 1/2 log of x squared plus 1. Sorry, we don't need the absolute value. There we go, plus c. This is the answer. All right. Thanks.